Microsoft has created a new form of quantum matter and a new processor to go along with it, apparently in an effort to avoid fixing bugs in Windows. The title here of this show is a bit snarky, to be sure, but the snark is going to continue because this is utterly stupid and ridiculous. Microsoft spokespeople have declared, including Microsoft engineers, that this new processor, this new quantum computing processor that they have created with brand new forms of quantum matter, which we will get into in a moment, will soon be able to, and this is an actual quote, design anything perfectly the first time, and quote, just give you the answer to any question. End quote. That may sound a little bit over the top, and it really, really, really is, because a little bit of a spoiler here, this new processor, this new groundbreaking quantum computing processor that they've just unveiled called the Majorana 1 currently can do nothing. Absolutely nothing. Let's read a little bit of this announcement from Satya Nadella, the CEO of Microsoft. Quote, "A couple of reflections on the quantum computing breakthrough we just announced. Most of us grew up learning that there are three main types of matter that matter. Solid, liquid, and gas. Today, that changed. After nearly 20-year pursuit, we've created an entirely new state of matter unlocked by a new class of materials, topoconductors, that enable a fundamental leap in computing. It powers Majorana 1, the quantum processing unit built on a topological core. We believe this breakthrough will allow us to create a truly meaningful quantum computer in not in decades, as some have predicted, but in years. The qubits created with topoconductors are faster, more reliable, and smaller. They are 1/100th of a millimeter, meaning we now have a clear path to a 1,000,000 qubit processor. Imagine a chip that can fit in the palm of your hand, yet is capable of solving problems that even all the computers on Earth today combined could not. Sometimes researchers have worked on things for decades to make progress possible. It takes patience and persistence to have big impact on the world, and I'm glad we get the opportunity to do just that at Microsoft. This is our focus. When productivity rises, economies grow faster, benefiting every sector and every corner of the globe. It's not about hyping tech, it's about building technology that truly serves the world." End quote. Okay, all right. A little bit of a primer here for those of you new to this sort of thing. Quantum computing works differently than normal computing. This is just the quick version. Regular computing, as we know it nowadays, is binary. Everything is based on ones and zeros, on and off, things in a binary state. We call those a Boolean. That is how the basis of all computing that we currently have. That is how computers work. Quantum computing does not use binary objects, so it does not have a 1 or a 0. Instead of a bit, which is a 1 or a 0, you have a qubit. Now, what is a qubit? Well, a qubit is, and this is really the technical description of what a qubit is, it's anything it friggin' wants to be. A qubit is a 1 or a 0, or both a 1 and a 0 at the same time, or mostly a 1 with some aspects of a 0, or a 0 that identifies as a 1 just to trick you. It could be anything it friggin' wants. It's insane. It's basically an almost unlimited number of possible states, and it's just almost impossible to predict what a qubit is. Now, Microsoft has been working on quantum computing for quite some time. They've been trying to push quantum computing forward because realistically, quantum computing has been at a position where it's not useful. There's been no value and use for quantum computing as yet. Last October, I did a show where I talked about how someone managed to get Doom to run on a quantum computer. But the thing about that was, it wasn't actually Doom running on a quantum computer. It was a very scaled down simulation of doom running on a quantum computer simulator, simulating a quantum computer that doesn't exist and had to be 70 times more powerful than the most powerful quantum computer on Earth. And in order to make it actually work, the quantum computer effectively had to then simulate a normal binary computer because there's just no way to make things work using actual quantum computing. You get that? So it had to be a regular binary computer simulating a quantum computer, simulating a binary computer. It still doesn't work that great. And even then, you need a computer that's 70 times more powerful than anything that exists. That's the state of where we've been at with quantum computing. Quantum computing in and of itself is inherently error prone, right? That's by design. It's just a giant hodgepodge of errors. Well, now Microsoft has announced this Majorana 1 chip, and that's going to change everything. Microsoft today introduced Majorana 1, the world's first quantum chip powered by a new topological core architecture that it expects will realize quantum computers capable of solving meaningful industrial scale problems in years, not decades. It leverages the world's first topoconductor, a breakthrough type of material which can observe and control Majorana particles to produce more reliable and scalable qubits. Okay, what are Majorana particles? Let's bring this up here. Fermions are fundamental particles or elementary particles, which means that they have no constituent particles. All known fermions, with the possible exceptions of neutrinos, are Dirac fermions. Yeah, I know, I'm losing a bunch of you already. These particles all have distinct antiparticles. A Majorana fermion or Majorana particle is a hypothesized fermion that is both a particle and its own antiparticle. It has the same properties either way. So that's what a Majorana particle is, and they finally managed to get those in theory real. They've managed to create them, or something that they think is them. Way to go, Microsoft. It's very cool. As I go through this, I'm going to continue to make fun of Microsoft and quantum computing and this new processor repeatedly. But I want to say this up front. I think some of the technology here is real cool. And I don't want to discourage Microsoft from working on some of this stuff, because even technology that goes nowhere is a heck of a lot of fun. In fact, look at this chip. If you're watching the video version, you can see this chip. This is the Majorana 1 processing unit. It's cool looking, right? It's cool looking. I dig it. Oh, look at that bad boy. That's cool looking. You know what, Microsoft? Keep making it, even if it is ridiculous. All right, we continue. In the same way that the invention of the semiconductor made today's smartphones, computers, and electronics possible, topoconductors and the new type of chip they enable offer a path to develop quantum systems that can scale to 1 million qubits and are capable of tackling the most complex industrial and societal problems. That's according to Microsoft. The Microsoft technical fellow says, quote, "We took a step back and said, okay, let's invent the transistor for the quantum age. What properties does it need to have?" All right. Let's scroll down a little bit here, because some of the statements that they make about what this thing can theoretically do and what it is currently capable of doing are hilarious. All right. This is a needed threshold for quantum computers to deliver transformative real-world solutions, such as breaking down microplastics into harmless byproducts, or inventing self-healing materials for construction, manufacturing, or healthcare. All the world's current computers operating together can't do 1 million, what a 1 million qubit quantum computer will be able to do. Whatever you're doing in the quantum space needs to have a path to 1 million qubits. If it doesn't, you're going to hit a wall before you... They're saying that they're going to invent this processor, and this processor is going to tell us all how to create self-healing materials and break down all microplastics. Why do they think that? It's a bit of a leap. You're going to hit a wall before you get to scale if you don't have a path to 1 million qubits, at which you can solve the really important problems that motivate us. We have worked out a path to 1 million. Okay. All right. So they're making this clear that in order to make these amazing things happen with quantum computing. They need 1,000,000 reliable qubits. Okay. So what do we got with the Majorana 1? What do they got? They're talking about how they fabricate everything atom by atom. They literally say that atom by atom they're fabricating this processor. The goal was to coax new quantum particles called Majoranas into existence. Okay, great, but how many qubits does the Majorana 1 have? Man, you're really burying the lead here. Commercially important applications will also require trillions of operations on 1,000,000 qubits. Yes, I've heard you say that, but how many qubits? Oh, here we go. Today, the company has placed 8 topological qubits on a chip. 8. The announcement today, the groundbreaking, earth-shattering announcement from Microsoft of the new this new quantum computer, that according to them, in order to be useful at all, needs like 1,000,000 qubits, has 8. So they've managed to build a processor that is 1/100,000th. A fraction of a percent of what is required to be useful. I'm sorry. The technology that they're doing here is cool. There's no doubt about that. It's very, very cool. But the claims of what they're going to do with it are off the charts, and they are so far from accomplishing anything. They only have 8 qubits. Again, they're right. With a handful of qubits, it's not like an 8-bit computer. Or okay, with an 8-bit computer, you can do a lot of stuff, right? If you have 8 bits to work with, it's limiting, right? But you can do a lot of things. With 8 qubits, you can't do diddly squat. Because in order for a qubit to function, you have to error check the qubit, because qubits are by design crazy error prone. I mean, that's the whole point of them, right? It's like going to ChatGPT and having a conversation about any technical and historical topic. It's just going to spit at you a lot of stuff. Some of the stuff will be right. Some of the stuff will be wrong. Some of it will be crazy hallucinations created by a billion if statements inside of the large language model that is ChatGPT and other related systems. That's how they work. Quantum computing is like that at the hardware level. Right? It's just a giant ball of hallucinations. That's part of why quantum computing is interesting. That's part of why I like that they're doing this work on quantum computing. It's a fascinating field of computing. But the whole underlying idea of it all is that it's a computer that is constantly, rapidly, almost faster than you can possibly imagine, hallucinating. Just constantly. So might it come up with some cool things? Yeah, it might. Might it also be wildly wrong almost all of the time? No, that's a for sure. So in order to make a quantum computer function well, you need far more qubits than you would an ordinary bit, because each qubit is mostly, for the most part, going to have to be error checking the other qubits. And then you're also going to have an actual binary computer to control, decipher, and manage the whole darn thing, and error check on top of that. The whole point of quantum computing at this point is error checking and error checking and error checking to get to the point where it's not that filled with errors. That's the goal with quantum computing. So when they say we need 1,000,000 qubits, it's not because we're doing 1,000,000 qubits worth of operations or dealing with 1,000,000 qubits worth of data and states. It's that we have to do so much error checking to make even the simplest, most rudimentary tasks viable and practical and accurate that we need 1,000,000 friggin' of them. But what they say, but Microsoft says, this 8-qubit CPU, 8, it can do nothing. It can do nothing. Remember how we talked about that quantum computer that theoretically could run Doom? That is like 1/bazillionth of the speed of what would be required to run fake, not quite functioning Doom. It's not joking. It's crazy. And they go on to say, but reaching the next horizon of quantum computing will require a quantum architecture that can provide 1,000,000 qubits or more. They say that this is the architecture, and they will get there in years, not decades. So they say this is just a couple years away. Are they wrong? Oh, heck, heaven, yes, they're wrong. Any engineer can look at this and say, yes, they're wrong. Million qubit machines should be able to solve certain types of problems in chemistry, material science, and other industries that are impossible for today's classical computers to accurately calculate. For instance, give us some for instances to get us excited. They could help solve the difficult chemistry questions of why materials suffer corrosion or cracks. This could lead to self-healing materials that repair cracks in bridges or airplane parts, shattered phone screens, or scratched car doors. What? Oh my gosh, we just put 8 qubits in a thing. In about 2 or 3 years, this processor is going to be so great. We'll be like, please make it so our car door doesn't get the scratches, or it self-heals itself. And when our bridges self-heals the cracks, okay, master, here's the result. And they just think that this is going to happen. That's insane. That's insane that there's so little logic going on. How the people building this can be so smart yet so dumb baffles me. From just a pure engineering perspective, this is retarded. Because there are so many types of plastics, it isn't currently possible to find a one-size-fits-all catalyst that can break them down, especially important for cleaning up microplastics or tackling carbon pollution. Okay, cleaning up microplastics, yeah, that seems like a good thing to do. Quantum computing could calculate the properties of such catalysts to break down pollutants into valuable byproducts, or develop non-toxic alternatives in the first place. They're basically just saying magic. Yes, any sufficiently advanced technology is indistinguishable from magic, right? And they're basically saying that they're going to get to a point with this technology where it's going to be able to do these magical things, including, quote, breakthroughs helping to eradicate global hunger. So they're going to do away with hunger. They're going to make it so we're going to get rid of all the microplastics. They're going to make all materials self-healing. Like just like magic stuff. This is going to start happening. But here's the thing. We're not talking about a technology here. None of this exists, nor is there any reason to believe that this could exist. Right? Like, no, what I'm saying is there's no reason to believe that this processor, this magic processor, is going to spit out these solutions. I'm not saying you can't have a self-healing material. I'm not saying you can't eradicate global hunger. What I'm saying is the CPU, there's no reason to think it's going to do that, right? I mean, there's no difference between what they're saying right now, and if you'd flash back in time to them with the Windows 95 launch, saying, with Windows 95, people will now be able to figure out how to eradicate global hunger, right? Does that make sense? No. Does it make even less sense with this processor than it did with Windows 95? Yeah, it makes less sense here. Windows 95, Windows Millennium Edition, was more capable of eradicating global hunger than this quantum computer is, because they've only figured out how to get 8 bits onto a chip. And even if they get to 1,000,000 qubits, or 8 qubits on a chip, even if they get to 1,000,000 qubits, there's still no reason to think that it's crazy. It's crazy. Most of all, quantum computing could allow engineers, scientists, companies, and others to simply design things right the first time. What? So this processor is going to be so good that you're going to sit down and be an engineer, and you're going to be like, I'm going to build a car. And you're just going to type car, and it's going to design it right the first time. So there's no such thing as iteration anymore. What Microsoft is saying is that iterating on things is no longer going to exist, because the moment you start the design process, the moment you begin, it is instantly designed right the first time. No iteration. That is stupid and retarded. Basically, Microsoft is saying we're going to do away with the scientific method and basic engineering principles. That's crazy. That is crazy. Goes on to say, any company that makes anything could just design it perfectly the first time out. See, they repeat it over and over again. Any company that makes anything could just design it perfectly the first time out. It would just give you the answer. The quantum... It would just give you the answer. This is the most overhyped I think I've ever seen Microsoft be. I don't think there's ever been a point in computing history where someone has come along with a processor, a computer, a piece of software, and just said, by the way, this is so great. Not only have we developed new types of matter, and we've used atoms, but these atoms that we've used, they're going to do everything. And everything's going to be perfect. And you're going to think of things and it's going to be perfect. And you're going to be like, I want an airplane. And boom, perfect airplane. No problems whatsoever because it's perfect. And you don't even have to think about it a second time because iterating is stupid and the scientific method is dumb. Don't even question it. Just perfect instantly. And you always have instantly the right answer to any question, no matter how big or small. And it's always perfect because this processor is so good. It's the stupidest thing. This is retarded. This is functionally retarded. The processor looks cool. The technology behind it is legitimately interesting. What Microsoft is doing here, and I really want to repeat this, is legitimately interesting. What they're saying about it is brain dead, zombie level retarded. Either every single human being that's talking about this is functionally retard, or they're just lying, or they fundamentally don't understand engineering, science, computing. It's crazy. I don't even know what to think of all that. But anyway, this is what's happening, and you're going to see a ton of coverage of this thing all over the place. And it's really important to remember, as everyone's talking about how this is going to change everything. One, that's just a made up thing. They just made that up because it sounds great. Two, there is significant reason to think that there's no way that's possible. And three, what they've actually created today doesn't do anything. As cool as that processor looks, it doesn't accomplish anything. It has 8 qubits in it. It's one of the least powerful quantum computers in existence. And the other quantum computers, the most powerful ones, can't run diddly squat. And when they do run diddly squat, it's because they're simulating a binary computer inefficiently. That's where we're at with quantum computers. Sorry. Yeah, it's ridiculous. Again, the technology is cool. It looks super neat. But no, this is flat out stupid. This is not going anywhere. But they're going to push it. And I guarantee you they're going to get a bunch of government money from it. Guaranteed, because Microsoft is working towards getting a big DARPA award. And they're going to be working with the government on this. They're going to be working with other corporations on this. And, no, this doesn't seem like it's going somewhere, but that's just me. Being right again. Thank you to all the Lunduke Journal subscribers. Go to lunduke.com and click on all the links. You love the links. The links at lunduke.com blow your mind. And with that, ladies and gentlemen, boys and girls, nerds and nerdettes across the inner tubes, I do declare and broadcast.